So I'm going to make a quick video on completing the square for those of you who were not in class on Friday. I have a purpose to this warm-up, which I actually would like you to do. I want you to factor and then solve each of these quadratic equations by factoring. Notice there's a pattern to these quadratics in that they are perfect square trinomials. So giving it away to these quadratics, and that is that they are perfect square trinomials. So these will simply factor to x plus 4 squared, x minus 11 squared. Notice this is a positive, but these were negative. And this also will be x minus 6 squared. So to solve, I will find the value of x. In this case, x is equal to -4. Here, x is equal to 11. And x is equal to 6. Okay? And there's a very specific reason that I am asking you to factor perfect square trinomials, because they're really easy to factor, and we're going to use that concept to do something called completing the square. Yay, another way to solve quadratics. Okay, so we've already learned to solve quadratics by using square roots. We're going to use that concept. We're also going to use the relationship between the coefficient of the x term, the b, and the constant term, the c, and we're going to look at that relationship. Notice here I've got x squared plus 6x plus 9. What's the relationship between that b and c term? Well, you'll see if I take half of the b term, so 6 divided by 2, and then square it, it'll give me my c term. So 3 squared does give me 9. Let's look at that again. If I've got a negative b term, if I take half of that, or -4, again, if I square it, I'm going to get a positive 16, my c term. So let's just try real quick to follow the same pattern. If I want to come up with my c value, I've got 14. I need half of that value, which is 7. Then if I square 7, I get 49. So the term I'm looking for here is 49. One thing to keep in mind, I always have to have an x term, the coefficient of this x term, be a 1. If it's not a 1, we're going to have to fix that, but we'll look at that later. All right, here's another example. I've got a b term of negative, thank you. It has to have a coefficient of 1 for my x squared term. I've got a b value of -3, so I'm going to take half of that. I'm going to square it, which will give me 9/4. If I'm going to factor that quadratic, so I'm going to set it to equal to 0, I'm going to factor it, I'm going to have x squared minus 3/2, remember that b term, and when I square it, that 3/2 gives me my 9/4. So I've got x squared minus 3/2 squared, so x is equal to 3/2. We'll talk about that in a second because it's not just 3/2. Come on. Oops. Okay, so your opportunity to fill in the numbers. If this is my b term, what is my c term going to be? Half of 2 squared is going to give me 1. Half of -6 squared is going to give me 9. Okay? So we're using this technique to complete the square, because we did notice that it was nice and easy to factor those quadratics that were perfect square trinomials. So I'm going to take this quadratic and I'm going to use it to complete the square. I'm going to back up for a second and tell you that x squared plus 8x minus 20, if I'm shifting this back over, equals 0. Because remember, when I'm trying to factor or solve a quadratic, it needs to be set equal to 0. The reason this is over here, is this a perfect square trinomial? No, which means I don't have an easy way of factoring it necessarily. So I'm going to kind of fake it by moving this 20 over to here so that it's out of my way and I can make a perfect square trinomial over on the left side. So I'm going to go back to what I had, x squared plus 8x, and then I'm going to put my 20 over here. So I'm going to add that number. Remember, we're looking for a c that I can add that makes it a perfect square trinomial. So half of 8, or 4, squared is 16. So I'm going to add 16 on this side. But if I add 16 on this side of the equal sign without doing anything on the right-hand side, I'm out of balance. So I have to add the same 16 to this side. So now I have x squared plus 8x plus 16 equals 36. I'm going to go ahead and factor this side. It's a perfect square trinomial. So I get, x plus 4 squared equals 36. So I also alluded to using square roots to solve. And so I'm going to take the square root of both sides, and I'm going to end up with x plus 4 equals, and if I take the square root of this, remember I have a positive or a negative number that will multiply to give me 36. So I've got a positive or a negative value of 6. So I know that x plus 4 is equal to plus or minus 6. So I'm just going to set up those equations. X plus 4 could be equal to a positive 6, or x plus 4 could be equal to a negative 6. So here, what are my x values? Subtract 4. I get x equals 2. Subtract 4, or x equals negative 10. So those are my two zeros, or solutions to my quadratic. Okay? Let's try that again. So I need to get this 1 out of the way because this is not a perfect square trinomial. So I'm going to rewrite this, moving the 1 over to the other side. I'm going to give myself space. So I'm going to set that equal to 1. I want this to be a perfect square trinomial. I need this to be half of negative 4. Negative 2 squared is 4. So again, I'm going to have to add that same 4 to the other side. So I've got x squared minus 4x plus 4 equals 5. I'm going to factor this. X minus 2 squared equals 5. Take the square root of both sides. I get x minus 2 equals the positive or negative value of the square root of 5. I'm going to leave this as a radical, and we're going to be talking more about radicals later in the week, but I'm just going to leave this as a radical. So to solve, I'm going to have to move this 2 over to find out my x value. So I'm just going to leave this as x equals 2 plus the square root of 5, or 2 minus the square root of 5. And I am absolutely fine leaving the solutions to this quadratic just like this. I actually don't want a decimal value. All right, so here are your steps, and I'm just going to walk through these quickly. You're welcome to write them down if you'd like. So the first thing we're going to do is we're going to write the equation in the form ax squared plus bx, and I'm going to move my c to the other side. I'm going to find half of my c value and half of my b value and square it. Then I'm going to add that value to both sides of the equation. Factor the perfect square trinomial, the part on the left-hand side. Then I'm going to take the square root of both sides, and then I'll write the two equations using both the positive and negative square root, and then solve. So I'm going to give you an opportunity to try this one on your own. Please pause the video, and then I will have this factored for you. So much like the same problem, I ended up, the c value I needed for a perfect square trinomial was 4. So I added that to both sides, took the square root of both sides, which ended up as x minus 2, and then square root of 10. Remember, I needed the positive or negative value of that. So moving the 2 over, I get x equals 2 plus or minus the square root of 10. And again, I'm going to leave it just like this. All right. Whoops. So you can also graph this on your calculator and check and make sure that you see these values, x equals -1 or x equals -9. All right, so I told you had to have a ax squared term that was 1, and this one is not. So I'm sure you can imagine what we need to do. We need to divide everything by -3, so this becomes 1. So I'm going to divide everything, that's left and right side had I had anything over here, by -3, so that I get x squared minus 4x, notice my sign change, plus 5 equals 0. And then I'm just going to solve just like I did before. You can do this on your own. Okay, so what happened here? I found in taking the square root of both sides, I would have x minus 2 is equal to the positive or negative value of a square root of a negative number. Remember, we can't take a square root of a negative number at this point, so no real solutions. Okay. All right, your turn. I've got a term that is not 1, so go ahead and pause the video, solve this, and check back for your answers. Okay, so I divided everything by -2, which changed signs on several of these. I came up with x minus 7 squared was equal to 36, and so my values for x were 13 and 1. My solutions, or zeros, were 13 and 1. All right, so this one's a little more complicated. I want you to see if you can try this one on your own. I will tell you that it'll be a whole lot easier to use fractions. Don't give up. If you keep going, you will find that you will get whole number answers. I will work this out for you, and I'll actually talk it through in a little bit, but please try this on your own first. Okay, so let's talk this through. I've got a rectangle and I'm looking for the area, so I need to multiply my dimensions. It says that my length was 7 longer than the width, so I've got a width and then a length that's w plus 7. So w plus 7 times w is my 120, or w squared plus 7w equals 120. So I'm going to take half of that value, 7 over 2, square it, which is going to give me 49 over 4. Add it to both sides. What I showed you over here is if I change that 120 into fourths, 480 over 4 is the same value as 120. I can add those together and get 529 over 4. So w plus 7 over 2 squared is equal to the positive or negative root of 529 over 4. So I've got w plus 7 over 2 equals the positive or negative value. 529 is a perfect square, folks. It's 23. So 23 over 2. My w then could be equal to -15 or 8. So let's think about this. If this is a real world example and I'm looking for a dimension, could my w be equal to -15? No, it couldn't, so this is an extraneous value. And I apologize that the writing's a little odd, but it's an extraneous value. So my dimensions are 8 over here. My width is 8, and my length is going to be 8 plus 7, or 15. All right, these are some examples for you to try on your own. I will show you the answer, but please pause the video and do these yourself. So if you have any questions, come on in and see me. You'll have to wait until Tuesday. I won't see you on Monday.